All right, so now we're wanting to find and sketch our special angles in radians. So these are the ones that you need to know for your non-calculator paper are 30, 45, 60-degree angles. So let's think about what those will be in radians. Well, we already know that if we measure out half a circle, so I'm going to go ahead and put in an x-axis here and a y-axis. All right, so if I measured out my half circle, I know that I'm going to call that pi radians. Well, we've got this one that we love, our 90-degree angle. That is half of half a circle. So that is going to be pi over 2 radians. So now this angle is going to be pi over 2. So let's think about our ratios. We know that pi over 2, if I make that triangle, it's just super, super tall. It has no adjacent side. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. And tan of pi over 2, well, tan of pi over 2 is opposite over adjacent. I can't divide by 0, so it's undefined. All right, let's keep going. Now, if I take this angle and take 1/3 of it, that's my normal 30-degree angle. 1/3 of pi over 2 is pi over 6. So now, coming back to my 90, if I take my 30-degree angle, of course, that's also 1/6 of pi, so 1/6 of half a circle. This is pi over 6. Cosine of pi over 6, well, I know that, I don't know why I wrote 2, pi over 6. My adjacent side is my long side, so that's going to be √3 over 2. Sine of pi over 6, well, if I go opposite the angle, I have my short side. I don't know why that's not straight down. That's a half. Tan of pi over 6, well, I get short side over long side, so 1 over √3. If I do a half divided by √3 over 2, both of those over 2's cancel. All right, let's go with our next angle, which is our equal angle. The 45-degree angle is half of 90, so half of pi over 2. Well, hopefully you just said to yourself that that is pi over 4. So pi over 4, I can also think of it as 1/4 of this. So that's pi over 4. I know in this case I have equal sides, so adjacent and opposite are the same. So cosine of pi over 4 is my equal side, √2 over 2. Sine of pi over 4 is my equal side, √2 over 2. Tangent of pi over 4, opposite and adjacent are the same. That's a ratio of 1. All right, lastly, well, actually not lastly, because I'm going to go all the way and look at the 0 as well. But now, if I want 60 degrees, well, 60 degrees is 2/3 of this angle, or 60 degrees is 1/3 of this. So my 60-degree angle is pi over 3. Pi over 3. And now, it's my opposite side that's long, my adjacent side is short. So cosine of pi over 3 is the short side, that's 1/2. Sine of pi over 3, that's the long side, √3 over 2. Tangent pi over 3, that's long side over short side, √3 over 1 is just √3. So notice I've written my angles in ascending order here. So pi over 6 is smaller than pi over 4 is smaller than pi over 3. So I think about those numbers with my angles, whether I'm talking about a short angle middle angle, or tall angle, just like I think to myself about long side, short side, or equal sides. So we talked about pi over 2 as our 90-degree angle. Alternatively, we also have the 0-degree angle. So my 0-degree angle is here. In my 0-degree angle, I have only adjacent and no opposite. And 0 is still 0. So pi over 2 is my 90, cosine of 0. So a 0 angle on the axis, that's my adjacent. It's all adjacent, so that's 1. Sine of 0 is 0 because there is no opposite. Tan of 0 is opposite over adjacent. 0 divided by 1 is okay, and that is 0. So these are the special angles that you need to remember, and you will be expected to know on any non-calculator assessments.